Hello friends, this video on NEET dual nature of radiation and matter is brought to you by examfear.com. No more fear from exam. Question number 7. The threshold frequency for a certain photosensitive metal is nu naught. When it is illuminated by light of frequency nu is equal to 2 nu naught, the maximum velocity of the photoelectrons is nu naught. What will be the maximum velocity of the photoelectrons when the same metal is illuminated by light of frequency nu is equal to 5 nu naught? So here you see this question is all about the relationship between the frequency of the incident light and the maximum velocity of the photoelectrons. So if you write the photoelectric equation, which is K max is equal to E minus phi. So K max, if you write it in terms of velocity, it would be half mv square, which is equal to h nu minus h nu naught. Right? So this is the form of the photoelectric equation where the velocity is linked to the frequency of the incident light. Right? Now let us write the equations for both case 1 and case 2. So in case 1, the light has a frequency of nu is equal to 2 nu naught. So in case 1, it would be half mv square is equal to h into 2 nu naught minus h nu naught. So this is 2h nu naught minus h nu naught, which is equal to h nu naught. Right? So our first equation would be half mv square is equal to h nu naught. So this is equation 1. Now let us write the equation for case 2. So in case 2 it says half mv square will be equal to, it is now illuminated with a light of frequency 5 nu naught. So this would be h into 5 nu naught minus h nu naught. So 5h nu naught minus h nu naught will be equal to 4h nu naught. So you can write half mv square is equal to 4h nu naught. So this is equation 2. Now in the question it is given that in the first case the maximum velocity of the photoelectrons was v naught. So that means in case 1 it is not v but v naught. So this is v naught. Okay. So now if you look at 1 and 2, what you do, you divide 1 and 2. So 1 divided by 2. So if you do that, it would be half mv naught square divided by half mv square is equal to h nu naught divided by 4h nu naught. So h nu naught will get cancelled, half m will get cancelled. So we can say v naught square by v square is equal to 1 by 4, or we can say that v square is equal to 4 v naught square, or v is equal to 2 v naught. So therefore the answer would be 2 v naught. Question number 8. Monochromatic radiation emitted when electron state on hydrogen atom jumps from first excited state to ground state irradiates a photosensitive material. Okay, the stopping potential is measured to be 3.57 volts. The threshold frequency of the metal is. Okay, so here the stopping potential is given as 3.57 and threshold frequency, that is nu naught, is something that we will have to find out. Okay, and how much is the energy of the incident radiation, that we can calculate from this data, that the electron jumps from first excited state to ground state. So therefore energy of the radiation would be energy at the first excited state, for which n is equal to 2, because ground state corresponds to n is equal to 1, first excited state would be n is equal to 2, and so on. Right? So the electrons jump from the first excited state to the ground state. So E, energy at n is equal to 2 minus energy at n is equal to 1. So how much is the energy? Now we know that energy at nth energy level would be equal to minus 13.6 divided by n square electron volt. So using this we can say E will be equal to minus 13.6 divided by 2 square minus 13.6 divided by 1 square. So this is equal to minus 3.4 plus 13.6, which is equal to 10.2 electron volt. So this much is the energy of the incident radiation. Now let us make use of the photoelectric equation. So as per that, EV0, which is equal to the potential energy, will be equal to K max, that is equal to E plus work function, that is H nu naught. So nu naught is something that we need to calculate. So nu naught will be equal to EV0 minus E. Okay, here it has to be negative, right? Because it's EV0 is E minus work function, correct? So nu naught will be equal to minus EV0 plus E divided by H. Now let's put the values. E is equal to 1.6 into 10 to the power minus 19. What is V0? V0 is equal to 3.57 volts plus E is equal to 10.2 electron volts. So change it into joules. 1.6 into 10 to the power minus 19 divided by H is 6.6 into 10 to the power minus 34. So once you calculate it, so you get the value of nu is equal to 1.6 into 10 to the power 15 hertz. So option C is the correct one. Question number 9. Light of two different frequencies whose photons have energies 1 electron volt and 2.5 electron volt respectively illuminate a metallic surface whose work function is 0.5 electron volt successively. Okay, so here work function is given as 0.5 electron volt. Okay, now what about the energies of the incident radiation? So here we have light of two different frequencies, right? So for the light of first type of frequency, we can say that half mv square or kinetic energy is equal to capital E minus phi. So capital E would be 1 electron volt minus phi would be 0.5 electron volt, which will be equal to 0.5 electron volt. For the second case, the kinetic energy half mv2 square would be equal to E in the second case will be equal to 2.5 electron volts minus phi is again 0.5 electron volt. So this is equal to 2 electron volt. So now let us divide these two equations. So 1 divided by 2, we will get half mv1 square divided by half mv2 square. So half m will get cancelled. So this is equal to 0.5 divided by 2. So 5 4s are 20. So you can say V1 by V2 will be equal to 1 by 2. Because here it was V1 square by V2 square and here it was 1 by 4. So 1 by 4 can be written as 1 by 2 square. So therefore we can say V1 by V2 is equal to 1 by 2. So the answer is A, that is 1:2. Question number 10. A photosensitive metallic surface has work function H nu naught. A photosensitive metallic surface has work function H nu naught. If photons of energy 2H nu naught fall on this surface, the electrons come out with a maximum velocity of 4 into 10 to the power 6 meter per second. When the photon energy is increased to 5H nu naught, then maximum velocity of photoelectrons will be. So again, what are the values which are given here? So in this problem, the problem tries to relate the energy of the incident radiation with the velocity of the electrons. So let us write the photoelectric equation, which says that K max is equal to E minus phi. So this can be written as half mv square is equal to E minus phi can be written as H nu naught, because phi is work function. So nu naught corresponds to the threshold frequency. Okay, and anyways in the problem it says that the metal has work function equal to H nu naught. Now let us write the equations for both the cases. In the first case, the energy is 2H nu naught and the velocity is given as 4 into 10 to the power 6. So in the first case, it is half mv1 square is equal to energy is 2H nu naught minus H nu naught, which is equal to H nu naught. So this is equation 1. Now let us write the equation for case 2, where velocity is something that we need to find out. So let's assume it to be V2, which is equal to, now the energy has been increased to 5h nu naught. So 5h nu naught minus h nu naught will be equal to 4h nu naught, and this is equation 2. So now what do? We divide equation 1 by equation 2. So we get half m v1 square divided by half m v2 square is equal to h nu naught divided by 4h nu naught. Correct? So here half m will get cancelled, h nu naught will get cancelled. So we can say v1 by v2 is equal to 1 by 2, or v2 is equal to 2v1. Now the value of v1 is given as 4 into 10 to the power 6. So v2 will be 2 into 4 into 10 to the power 6, which is equal to 8 into 10 to the power 6 meter per second. So this would be the correct answer.
Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.